Hey everybody, good day. Mr. Smith here, and the purpose of this video is to carry on with my review of one-step equations. The target audience where I teach is grade 9s, but any middle school students could probably use this as a review. Um, Decimals and fractions don't really operate any differently from whole numbers. Sometimes they look a little scarier, or some students might be intimidated by the fact that we've gone from whole numbers to decimals or fractions. But really, the strategies, the tools, how you approach the problem really doesn't change. Okay, the goal of algebra is to isolate the variable. It's to get the variable by itself. So if you're getting the variable by itself, that usually involves one of the four basic operations: multiplying, dividing, addition, subtraction. And of course, later on, you'll have to deal with exponents and brackets and distributive property, all that stuff. But for our purposes today, I just want to kind of prove to you, if I can say it that way, just prove to you that decimals is really no different from whole numbers. Okay, so let's have a look at the first example I've got here. Just going to just choose a color here. I'm going to go with, well, let's do with orange. Okay, so you have z minus 6/10 is equal to 3 7/10. Okay, so what have we got here? We've got subtraction. So what is the opposite of subtraction? We're always trying to do something with our numbers, whether they're a coefficient on the variable or a constant. The opposite of subtraction is addition. So why not add 6/10 to both sides? Okay, so we're going to add 6/10 to both sides. Now, what effect does that have over here on the left side? Well, when you have subtract 6/10 and add 6/10, essentially they zero pair each other out. Okay, they cancel. So over on the left, we have a good thing going on. We have z by itself. And then if we add the 0 and 6/10 to 3.7, well, you've got 13, carry the 1, so you have 4.3, okay? 4.3. And yeah, you could check that, okay? You should get in the habit of checking your answers, because I know this question might seem fairly simple, but when you get onto more difficult questions, you'll want to develop the habit of checking your answers. So does 4.3, we've swapped in the 4.3 for the z. You'll hear me use 0.3 even though it's supposed to be 3/10. That's a bad habit I have. So we swap in 4.3 for the z, and then we actually see if that's actually true. So over here, of course, we can just carve out some space. And let's borrow and regroup. So 13 minus 6 is 7, and 3 minus 0. Okay, so it checks. All right. Okay, fairly straightforward. Let's do the next question. Okay, this time I'm going to go with purple. All right, over here you have 6.3 equals 2.3 plus b. Okay, I just wanted to point out that it's okay to have the variable on the right side. All right, some students will want to rewrite this question as b plus 2.3 is equal to 6.3. Some students develop a need or a habit to have the variable all on the left. And my feelings on that are, it's okay to do that rewrite. You can rewrite the question. You can flip the left for the right because the equal sign doesn't care. But I would encourage you to get used to the fact that sometimes your variables will be on the right side, and it's not that big of a deal. And to that point, sometimes this constant will come first, right? And so it could be written like this. Either way, no matter whether you have the variable on the left or the right, and the constant comes second or it comes first, you have to develop the ability to look at a question, no matter how it's written, and be able to deal with it. Okay, so I'm going to deal with this question the way it's written. So there's no operation in front of the 2.3. There's an equal sign, but we do have a sign. The sign is positive. So just like we think of subtraction as the opposite of addition, we can think of negativity, or the negative sign, as opposite to the positive sign. So in this case, why don't we And it depends on how you want to think on it, but it's really the same thing. We could say, let's add a negative 2.3 to both sides. Or some of you will think, well, aren't we just subtracting 2.3 from both sides? And the answer is yes to both. You can think of it as either adding the negative or just simple subtraction. It's up to you. Either way, we get a zero pair here, which is great because that leaves us with a b on this side. Okay, over here, well, you get a simple subtraction. 3 minus 3 is 0. 6 minus 2 is 4. So you got 4.0 is equal to b. All right? Now, again, you can check that. Okay, so 6.3 is equal to, that's not a very nice decimal. So 6.3 is equal to 2.3 plus, and what is b supposed to be? See, these are interchangeable now. I mean, that's what the whole point of getting solution is, because now we have a numerical value. We have a number that can replace the b. So instead of writing a b, like I did over here, the way the original question is set up, of course, I can replace that b with a 4. The b is a 4 because that's what the solution told us it is. So 6.3 is equal to, does 2.3 plus 4 equal 6.3? Yes, it does. Okay. Again, I'll be picky about my decimals. Okay, so 6.3. Okay, that works. All right, next, last question. Okay, so we have 9.6 m. Sorry, let me start that again. 9.6 plus m is equal to negative 0.4. Okay, so we've got 9.6 plus m is equal to negative 0.4. Well, again, just like this, we do have a sign. There's no real operation in front of the 9.6, but it does have a sign. The sign is positive, so you can use the opposite of that sign, and that is negative 9.6. Whatever you do to one side, you do to the other. That cancels out. That becomes a zero pair. And you have m is equal to negative 0.4 minus 9.6. Okay? Now, I'll just point out, some students would choose to read this, and it's the same thing, 0.4 plus a negative 9.6. These two interpretations are the same, okay? In other words, if you look at this, like if you're treating this sign over here as subtraction, then the sign on this now becomes positive. So we know from our integer rules that subtracting a positive is the same as adding a negative. Okay? Those are the exact same things. So whether you choose to interpret it as subtracting a positive 9.6 or adding a negative 0.6, and that's kind of the way I wrote it. Essentially what I'm doing here is I'm choosing to add a negative 9.6 to both sides. I'm adding a negative 9.6 to both sides, okay? So when you add two negatives together, you just get a bigger negative. Okay, so this should be negative 10. And same interpretation over here. If we're taking away this positive, we should get a negative 10. Not just should, we do get a negative 10. Okay, so you can check this. I'm just going to switch the color for the checking. So you can check this. So now we're saying the original question, 9.6, here's our m. We're saying because our solution told us this, that the negative 10 will replace the m. So we have 9.6 plus negative 10 is equal to negative 0.4. Okay, is that true? Yes, it is. If you have 9.6, take away 10, you're going to have 0.4. Negative 0.4, that's equal to negative 0.4. Okay? Now, if you're wondering how to do this operationally, basically what you have to do is you have to subtract, you start with the larger number, and you subtract the smaller number, okay? So this becomes a 0, that becomes a 10, borrow, and we get a 4. And 9 minus 9 is 0. Now, what it says in our integer rules is that these two numbers kind of go to war. They fight. And the sign of the larger number wins. It prevails, okay? You take the sign of the larger number. On a number basis only, 10 is larger than 9.6. So since the 10 has a negative, it's still negative over here. We just rearrange it always to subtract the smaller from the larger because it makes the subtraction easier. But we must sort of intuitively or understand at a deeper level that the actual answer is negative because the sign on the larger number is negative. Okay? Just thought I'd point that out. So our answer is negative 0.4. And we checked it and that worked. Okay, so one more question? No, that's it. Okay, so that's it. And the next section will deal with fractions. Okay? Talk to you later.